this video, we are going to explore the practical aspects of configuring Ether channels. We are going to talk about the static Ether channel configuration, we are going to talk about PEG-P configuration, and we are going to explore LACP. Let's go to our whiteboard to take a look at the network we'll be using in this case. I'm going to have just two switches. I'm going to have my Cat1 connected with two links to Cat2. These links are going to be Fast Ethernet 23 and Fast Ethernet 24 on both sides of this connection. Also connected to Cat1, I'm going to have my Wireshark station connected to Fast Ethernet 03, where I'm going to send LACP and PEG-P frames when I use one of these two protocols to explore what's happening in the negotiation. But first, let's explore configuring static Ether channels. I'm going to start that on Cat1. The first thing that I'm going to do is I'm going to make sure that my ports are properly configured. Here they are, Fast Ethernet 23 and 24 on Cat1, default configuration. I haven't configured anything on these two ports. So on Cat2, this is Fast Ethernet 23, and this is Fast Ethernet 24. No configuration at all, just the default configs. I can also see that I have CDP neighbors, which means that Cat1 and Cat2 can actually see each other. Let's configure Ether channel between these two ports. To configure Ether channel, you may recall these guidelines. I first said that we need to configure physical port members. I'm going to configure these ports as layer 2 in this example, but I can configure them as layer 3. It doesn't matter. Ether channel will support both layer 2 and layer 3. I'm going to choose the protocol, and in this case it's going to be static, so just simple mode on. And I'm going to assign these ports to the Ether channel in use. Since I'm using Cat1 and Cat2, a good choice for Ether channel number is, I would say, 12. Or I can use 1. Any number will do. The number is almost irrelevant. I will show you later on when the port channel number actually comes into relevance. Finally, I'm going to configure the logical interface, the port channel interface, which will get created for me automatically, but you remember that I don't actually trust iOS in all cases. And finally, I'm going to explore the load balancing mechanism that we use in our case. So, going back to my terminal, I'm going to start from Cat1. I'm going to say interface range Fast Ethernet 23 to 24. What I like to do always when I'm configuring Ether channels is I like to start by shutting these interfaces down. So I'm going to bring them down, and then I'm going to say channel group 12 mode, and here I have to choose which protocol to use. I can use LACP active, I can use LACP passive, this is not what I want to do now, or I can use desirable or auto for port aggregation protocol. In my case, I want to use mode on. And as you can see here, iOS tells me that the port channel interface 12 has been created. If I do show run interface port channel 12, I should have this interface created. It may or may not happen automatically. You remember, I don't really trust iOS. Let's configure the same thing on Cat2. Interface range, Fast Ethernet 23 to 24. I'm going to start by shutting the ports down. I'm going to say channel group 12 mode on. Now, I should point out here that in my case, on both sides of the link, I have created Ether channel 12. So on this side here, I have created port channel 12. And on this side here, I have also created port channel 12. This doesn't have to be the case. I can use different number here and a different number here, and my port channel will still be okay. But to avoid confusion, to avoid troubleshooting nightmares, as I like to call them, in production networks, you should try really to match port channels on two sides of your link. You don't have to, but it's a good common practice. So going back to my Cat2 now, I'm going to do no shutdown on my physical ports. They are now going to change state from administratively down to just down. On Cat1, I'm going to do the same thing. And let me clear the screen so that we can see what is happening. Now, what I can see here is that interfaces change state to up. Then I have line protocol on the interfaces changing state to up. And then I can see that the interface and the line protocol on port channel 12 changed state to up. So my Ether channel is now actually operational. How can I confirm that? Well, there are multiple commands that you can use for this case. The most common one, the simplest one to use, is show Etherchannel summary. When you run show Etherchannel summary, what you are going to see is all the Ether channels that you have configured on your switch, and you are going to see what's the status. For example, here we have information that for group 12, our port channel 12, I have port channel logical interface PO12 that has these flags, S and U. Now, these flags mean S, that this port channel is operating as layer 2 Ether channel, and U here means that it is actually in use. Mind you, we are looking at the uppercase U, not the lowercase u, which means that the interface is unsuitable for bundling. This is what you want to see. This is good. Now here, in this section here, we see the ports that are actually in the bundle. We can see that we have 2 ports in the bundle, 23 and 24, and here I have flag P associated with them, and P is a good thing, which means that this interface is bundled in a port channel. I should be seeing similar output on Cat2. So if I do show Etherchannel summary on Cat2, I should be seeing similar output. I can see that port channel 12 is a layer 2 channel and it's in use, and I have ports 23 and 24 which are bundled in port channel. This is good. But this is not the only verification command you can run. Let's go back to Cat1 and let's take a look at other options that I have for show Etherchannel. And as you can see, I have quite a few of them. We explored summary, but let's take a look, for example, at the command show Etherchannel port. This information here, this command will show me more detailed information about the members in the port channel. For example, here, I'll just highlight port 23. I can see here that this port is up and it's a master in bundle. What does master in bundle mean? This means that this port is the port that was the first to come up, and this will be the port that lent its MAC address to the port channel interface. Let me show you that. If I do show interface port channel 12, this is the MAC address that I'm seeing here. Let's take a look at show interface fastnet 23. Take a look at this. It's the same MAC address that I actually copied in my clipboard, so I can see it here. This is the same MAC address as the first interface in the bundle to come up. Now, if I do show Etherchannel port, I'm going to see something unusual, and those of you with sharp eyes, you may have noticed it as well. Take a look at the port state on fastnet 24. It also says it's master in a bundle. This is a cosmetic error. This is not a master in the bundle. This port here is master in the bundle. This should here, this highlighted bit here shouldn't show up for port 24. But you know what? Cosmetic errors happen from time to time. Another command that you can use to verify the status of your Ether channels is show Etherchannel port channel. Now, this here will show you pretty much the same information just from slightly different angle. It will show you the information about the logical interface, and then just a quick summary of the ports that you have in the bundle, the physical ports. Also here we can see the number of ports in the bundle. It says 2. The switches that I'm using are Catalyst 3560s. These are desktop switches, the LAN switches. These don't have all the capabilities as some higher-end switches, like for example Cisco 6500s have. On those higher-end switches, there is an additional configuration that you can configure for Etherchannels, and that is to configure the Etherchannel to only come up when a certain minimum number of ports in the bundle are actually operational. Let's say that you wanted to have 8 links between Cat 1 and Cat 2, but you wanted the port channel to be up only if, say, 6 of them are up. You can do that on 6500 switch, but you cannot do that, unfortunately, on 3560 and other desktop switches. It's just sad fact of life. But moving on, there is another command that can show you the output of these two commands combined, and this is show Etherchannel detail. When I run this command here, the first thing that I'm going to see information about the ports in an Etherchannel. This is pretty much the same output that I would get with show Etherchannel port. And when I go down, I'm going to get the same information that I had with show Etherchannel port channel. So with show Etherchannel detail, I'm going to see the combined output of show Etherchannel port and show Etherchannel port channel. Last but not the least, I have show Etherchannel load balance. With show Etherchannel load balance, I'm going to see which is the Etherchannel load balancing configuration that is active on my switch. And you may recall that the load balancing is configured globally per switch. It's not configured per Etherchannel. Also here, I can see what is going to be the load balancing mechanism used for non-IP traffic, what is going to be used for IPv4 traffic, and what is going to be used for IPv6 traffic. So this is the basic configuration of Etherchannels using no negotiation protocol. Let's take a look at PEG-P. Just a quick reminder of the two PEG-P modes. PEG-P operates in a silent mode called auto mode, where frames are not sent, the negotiation frames are not sent by default, and they are only sent in response to received PEG-P frames. In desirable mode, PEG-P frames are sent as soon as the link comes up. To explore PEG-P, we are going to use the same network that we configured now. The only difference is I'm going to start with only Fast Ethernet 24. So I'm not going to be using Fast Ethernet 23 to begin with. I'm just going to have one link between my Cat 1 and Cat 2. Also, I'm going to configure the span feature on my Cat 1 switch to send PEG-P frames from Fast Ethernet 24 to the Wireshark that I have configured. So to start with, I'm going to delete the previously configured Ether channel. So I'm going to delete the interface port channel 12, and I'm going to default interfaces Fast 23 and Fast 24. I want them in their default configuration. And I'm going to do that on both Cat 1 and Cat 2. So no interface, port channel 12, default interface, interface range, FastNet 23 to 24, and actually I'm going to shut them down on Cat 2. And I'm only going to keep interface FastNet 24 operational. I'm going to do the same thing on Cat 1. So if I do show CDP neighbor now, I should be seeing that Cat 2 is the only neighbor I have. Now let's configure the span. So I'm going to say monitor session 1 source interface FastNet 24, and I'm going to send all this traffic to the interface Fast Ethernet 3, and I'm going to preserve any VLAN tags or encapsulation if I have it. Finally, I'm going to bring out the interface fastnet03 from shutdown. Let's go back to our Wireshark, and I'm going to start capture on Cat1. I should be seeing some frames like spanning tree, the keep alives and so on, but I'm not interested in any of them. The only frames that I'm interested in are PEG-P frames. So I'm going to apply the filter here. In my Cat1, I'm going to go to fastnet24 and I'm going to say channel group 12 mode auto. So I'm going to create an Ether channel configured only on fastnet24 in a silent negotiation mode. Let's take a look at our Wireshark. As you can see, no frames have been captured. The reason is because fastnet24 is now not transmitting any PEG-P frames. Remember, they will be sent only in response to the initiated negotiation from the other side. This was the first thing I wanted to show you. Going back to my terminal, if I do show Etherchannel summary, this is what I should be seeing at this point. Remember, Etherchannel is not configured on the other side. So what I'm seeing here is that group 12 with port channel 12 as the interface is operating in layer 2 mode, but I have the flag D here, and D stands for down. I can also see that I'm running PEG-P as the aggregation protocol, and I can see that I have port fastnet24 as the member, but instead of P flag here, which means that it's bundled in the port channel, I have I flag. And I flag means that this port is now operating in a standalone mode. It failed to negotiate Etherchannel. Going back to our Wireshark, we still have no PEG-P frames. Let's shut this port down. What I'm going to do now is I'm going to change the channel group 12 mode from auto to desirable. And now I'm going to do no shutdown. Going to my Wireshark, now I'm seeing quite a few frames being transmitted. Let's take a look at this frame. I want to show you a couple of things, and please keep in mind, PEG-P and LACP are relatively complex protocols. I'm not going to dissect them in great detail. PEG-P is Cisco proprietary, which means it's not very well documented. It's actually not documented at all how it operates. And LACP is documented in 802.13, I believe, AX document, which is very, very long document. And to be honest, I haven't spent a couple of weeks of my life reading through it so that I can compress this information in a couple of minutes. But I know enough about it, I read enough of that document so that I can show you the important bits in these messages. So what I'm seeing here, the important bits are, this is transmitted by Cat1. How do I know that? Well, for one, only Cat1 is configured with Etherchannel right now. Cat2 isn't, so all the frames that I'm seeing here are transmitted by Cat1. Also, I can look at the MAC address here, and I can see it's the last 3 bytes are 0C5E9A. If I go to Cat1, this is what I should be seeing, 060C5E9A. So this is what I care about. These are the last 3 bytes. Now let's take a look at the PEG-P protocol here. What we are looking at here, this is the first thing, the first important bit. And we're going to see this in LACP as well. It's just that they are called differently. This is the local device identifier. And as you can see, the local device identifier does not match the source MAC address. The reason why it doesn't match the source MAC address of the frame is that this MAC address is something that we call the base MAC address, also sometimes referred to as the system MAC address. Depending on the platform you are using, the system MAC address will be different. On CAT switches, in most cases, you can find that out using show version include base, and we're going to see the base Ethernet MAC address. This is usually the MAC address which is by 1 lower than the lowest MAC address in use on your switch. And again, I'm saying this is very, very, very platform dependent. On 3560, I can see that Gigabit 01 interface here is using this MAC address. This is the lowest MAC address on the switch used by an interface on the switch. And I can see that the base Ethernet MAC address is exactly by 1 lower than this. So this is true on most of the fixed configuration switches. On modular switches like, for example, 4500s or 6500s, this will be probably the MAC address that is by 1 lower than the lowest port number on the supervisor module. The line card modules don't come into play for determining the system MAC address or the base Ethernet MAC address of the switch. But that was a very, very brief digression. Let's go back to our Wireshark here. So this is the local device identifier. The reason why device is identified in this negotiation is because we can have multiple links between our devices. And generally speaking, we are not supposed to form Etherchannel with multiple devices. So if I'm configured to speak Etherchannel with one other device, and by mistake another port member is connected to a different device, I'm going to use this value, the value of the local device ID and the remote device ID that I will see later on, to determine that I'm actually connected to the same device. If I'm connected to 2 devices, I cannot successfully negotiate Etherchannel, except in some special cases like VSS. The next thing that I want to show you is the local sent port interface index. This is the value determined based on the SNMP interface ID. And I can see here 10024, the important bit of course being 24. 24 here means that this is port 24 sending this traffic. The next thing that I want to show you is the local group interface index. This will be 0 at the beginning of the negotiation. This is the interface index used by the port channel interface, by the logical port channel. First few frames will have this value set to 0. But as the frames are being sent out and eventually we hear no response to them, this will change to the same value as the local sent port interface index. If you see this in your captures, if you are using Wireshark to troubleshoot your network, this means that the Etherchannel has not formed. We failed to negotiate Etherchannel because there was no response from the other side. I will show you later on how it looks when it actually works properly. And the rest here, we have the information about the partner. This is the information about the remote switch. And as you can see here, it's all going to be zeros and unknown values. The reason is there is no partner on the other side. Let's go back to our terminal, and I'm going to shut the interface down, and on my Wireshark, I'm going to restart the capture. I want to start from scratch. On Cat2 now, I'm going to say channel group 12 mode auto. So I want to now successfully negotiate Etherchannel. On Cat1, I'm going to say no shutdown, and let's go to Wireshark and see what happens now. Now I can see here immediately that I am sending a frame. This was sent by Cat1, but this is response from Cat2. You can see 17 here instead of 0C. That's important. So this was the original frame that was sent. And as you can see, I have the local information here, just as it was before. And this is the response received from Cat2. Now we can see that also local send port if index is 10024 because it's the same one on the other side. But now from Cat2 we are actually seeing the partner information. And as we go down through our negotiation here is, as we scroll down, eventually, and it happened right here, we are going to have the local group if index is going to change to a value that doesn't match this port. This means that we have had a successful negotiation of Etherchannel. Even though we are using just one port, you can have Etherchannel on one port. It doesn't make much sense, but you can do it. Let's go back to terminal and confirm that our Etherchannel is actually properly operational. So I'm going to do show Etherchannel summary, and here I have it. Now, port channel 12, I can see it operates in layer 2 mode. I can see that it is actually in use, and that we are using protocol PAGP, and that port FastInit 24 has been bundled in an Etherchannel. I can also do command show Etherchannel protocol here, and it will show me very brief summary of which groups are using which protocol. This will be empty if you are using no protocol. So this was configuration of PAGP. Let's take a look at Link Aggregation Control Protocol, the LACP. Again, a quick reminder about LACP. Similarly to PAGP, it supports two modes of operation. It supports silent passive mode, in which case no LACP frames are sent except in response to received LACP frames. It also supports active negotiation, in which case the frames are sent instantly when the interface comes up. This is the network that I will use to explore LACP. As you can see, it's identical to the network I used for PAGP. I have only one interface to be bundled there. I'm just looking at the protocol. I'm not looking at actually Etherchannels working right now. So let's go to our terminal and let's unconfigure what we have done previously. So I'm going to go to FastInit 24. I'm going to shut this interface down. I'm also going to, let's just default it. So this is going to remove all the configuration in FastInit 24. I'm going to say no interface port channel 12, and I'm going to do the same thing on Cat2. So default interface FastInit 24 and no interface port channel 12. Now, what I'm going to do is, again, I'm going to go to my Wireshark and make sure to restart my filter. I'm to restart my capture, and I'm going to remove the filter because I'm no longer interested in PAGP frames. As I can see here, I'm receiving a lot of other traffic. So going to terminal here, this is the configuration FastInit 24 on Cat1. And this is the configuration on Cat2. On Cat1, what I'm going to do on FastInit 24, I'm going to say channel group 12 mode, and I'm going to put it in passive mode. Going to my Wireshark, I see a lot of frames going on, but none of them appear to be LACP frames. Let's put in the LACP filter here. As you can see, Wireshark doesn't seem to recognize LACP as the valid value. What I need to do here is I need to configure Wireshark to display ether type 0x8809, which is LACP. If you can't remember this, you can use the alias for this ether type, which for whatever reason in Wireshark is called slow. So what I want to see are slow protocols. And as we can see, there are no frames flowing. This is because I have configured my Etherchannel in a silent passive mode. Let's change this to active. So I'm changing the channel group 12 from mode passive to mode active. Now, when I go to my Wireshark, I see quite a few frames flowing. Let's examine this protocol. Let's examine LACP. The first thing that I want to show you is the actor system priority. This is the configured system priority on this switch. This is something that for LACP, can be configured. It's a global configuration on the switch, LACP, and then system priority. The next thing here is the actor system. Similarly to PAGP local identifier, this will be the system MAC address, the base MAC address of this switch. And as we can see, this is true. The actor key is our local Etherchannel number that we configured. Actor port priority, here we can see 32,768. Remember, the port priority will be used as a tiebreaker in a case that we have more than 8 links in bundle. The lower port priority wins. So ports with higher port priorities, higher numerical values, but that means lower actual priority, will be less preferred to be bundled over those who have high priority, which means lower numerical value. Also, here we can see the actor port. This is just some local identifier for the port. Also, below here, we can see some more information about the partner. And because we have nothing configured on the other side, we are going to see all zeros. So let's go back to our terminal and let's shut the port down. So I'm going to do interface fastnet 24 and I'm going to do shutdown on this port. Then I'm going to go to cat2 and on interface fastnet 24 I'm going to say channel group 12 mode passive. So now I'm going to turn on Etherchannel. Going to Wireshark, I'm going to restart the capture because I want to observe these frames as they are flowing, and then I'm going to do no shutdown on cat1. Let's see what happens. What I can see here are the frames coming in from cat1. As you can see, the first couple of frames are sent, and what I'm looking for here is the partner system. The partner system here says all zeros because I have not yet heard from cat2. This is the first frame from cat2. We can see the actor system, our local information, is set to our local MAC address, to our local base MAC address, but we have here now information about the partner. And as you can see, our keys here match. Does this mean that I have to use port channel 12 interface on both sides of the link? Well, not so. I can use any key on both sides of the link as long as all the links that are being bundled are actually using the same key. Let me show you this in the whiteboard. So if I added another link to our mix here, let's say our port fastnet 23, and if I used key, let's say instead of 12 on this side here, if I used port channel, let's say 21, and on this side I used port channel 12, this would be okay configuration. Let me show you that. So I'm going to go to my terminal. I'm going to shut the interface down on cat1. And on cat2, I'm going to default interface fastnet 24. And I'm going to say no interface port channel 12. Interface fastnet 24, I'm going to say channel group 21 mode passive. So now port channel 21 gets created. I'm going to go ahead and restart the capture on my Wireshark, and I'm going to do no shutdown on cat2. Let's see what happens. When the interface comes up, I should be seeing some frames here. Oh, maybe I shut it down on cat1. Let's see if that's the case. Yes, I did. There we go. So this is the frame. Actually, no, it happened in slightly reversed order, but that's okay. So this is the frame here that I'm receiving from cat2. You can see that my actor key is 21 and that the partner key is 12. This is the frame coming from cat1. You can see my actor key is 12 and the partner key is 21. And you can see that they are here performing some sort of negotiation. Is my port channel now up? Let's take a look. On cat1, if I do show Etherchannel summary, what I'm going to see here is that this is a layer 2 Etherchannel, which is in use using LACP as the protocol, and FastNet 24 is bundled in a bundle. What about Cat2? Show Etherchannel summary, here I see the exact same information, except on this side here I'm using port channel 21. Let's add port 23 to the mix. So on Cat1 I'm going to go to interface FastNet 23 and I'm going to say channel group 12 mode active. I'm going to do no shut here, and on Cat2 I'm going to go to port 23 and I'm going to say channel group 21 mode passive, and I'm going to say no shutdown on this link. When this interface comes up, and let's give it a moment, there it is. If I do show Etherchannel summary, I can see that now I have ports 23 and 24 in the bundle, which means that this setup is now fully operational. But let's break it a little bit. Let's, instead of having a single Etherchannel on Cat2, let's try to build a misconfigured Etherchannel by having two of them configured. So one of them here is going to be, let's say, port channel 21, and this one here is going to be member of port channel, let's just say 22. Now, on Cat1, both of these interfaces here are going to be in port channel 12. Let's see what happens in this particular case. So I'm going to go to Cat2 and I'm going to say interface range. Actually, I can just do interface FastNet 24. I'm going to say shutdown, and I'm going to say channel group 22 mode passive. So if I do show Etherchannel summary, I should see two Etherchannels configured. Let's do interface range FastNet 23 to 24. Let's do shutdown. Okay, so now all my physical interfaces are going down, I'm sorry, and let's do no shutdown. Let's see what's going to be the result of this. I can see my physical interfaces changing state to up. Let's wait for line protocols to go up. There I have port channel 21 coming up, but what's happening with port channel 22? Let's take a look. If I do show Etherchannel summary, I can see here that port channel 21 is fully operational. It seems to be okay. Port channel 22, though, says it's a hot standby. Why? If I take a look at Cat1, I can see that port channel 12 is up. Port 23 is bundled in the link, but port 24 is in a suspended state. Why is it in suspended state? Well, let's take a look. So if I go back to my whiteboard and I give you just a brief example of this. I have Cat1 and I have Cat2. I have two links between them. Cat1 is on this side saying that its own key is 12. On this side, it's saying its key 12. And remember, there is that information about the local system MAC address. So let's just say that there is information that it is coming from Cat1. On the other hand, Cat2 here, which I didn't write, sorry, Cat2 is responding here saying that this is a packet coming from Cat2 and it has key of 21. On this side here, I'm saying information, sending information, this is Cat2 with key of 22. When this information arrives to Cat1, Cat1 is going to say, okay, I'm neighboring with Cat2 and the other side is using 21 on what is my local key 12. This is okay, there is no problem with this. But then I receive this frame here, which tells me that this is cat2 that on my key 12 is attempting to use a different key than the key that I already used. This is not good. I am detecting a misconfiguration, and this link here is going to be suspended. On cat2, this one here is going to go into hot standby state, because as far as cat2 is concerned, this is not necessarily a misconfiguration, just something that it cannot use directly. It will be the cat1 that detects this as a problem. A similar detection of this problem exists with port aggregation protocol. The only thing is that instead of using the key, we are going to use that group interface index, but it behaves in pretty much the same way. But what if we have no protocol running? What if we have statically configured Ether channels on both sides and they are misconfigured in this particular fashion? Is this going to break? Are we going to completely destroy our network? Or is there some mechanism in place to detect this sort of a problem? Well, as it turns out, there is a mechanism. It's called Etherchannel Guard. Let me show you Etherchannel Guard in action. To do that, I'm going to go back to terminal and I'm going to default interfaces Fastnet 23 and 24. I'm going to remove port channel 12 on cat1, and on cat2 I'm going to do pretty much the same thing. Default interface range Fastnet 23 to 24, and I'm going to say no interface port channel 21 and no interface port channel 22. I'm going to go into Fastnet 23 and 24 and shut them down on both sides of the link. On cat1, I'm going to say channel group 12 mode on. So this will create an Ether channel in a static fashion, that means with no protocol, on cat1. So I'm going to say on interface Fastnet 23, I'm going to say channel group 21 mode on, and here I'm going to say channel group 22 mode on. Show Ether channel summary. These will be down because the interfaces are actually in shutdown. But let's bring them out of shutdown. So on cat1, again for 19th time I believe, this is what I'm going to see. You've seen this many times, but let's see now cat2. Show Ether channel summary. What I see now is that both of these Ether channels are actually operational. But what I have now is really a Y connection between them. What I have is cat1 and cat2. From a logical perspective, it looks like this. So this is port channel 12, this is port channel 21, and this is port channel 22. But there is no protocol running here that cat1 and cat2 can use to detect this situation. Well, as it turns out, there is a protocol running. It's called spanning tree. With spanning tree BPDUs, when we are sending them, port channels are perceived as logical interfaces. That means that cat1 will be sending one set of spanning tree for BPDUs sent from this logical interface, from the MAC address of this interface. Port channels, by nature, by definition, are point-to-point. We cannot have multiple hosts there. So what we are expecting on cat1 is to receive one set of spanning tree BPDUs. But here we are going to be receiving two sets. One set sent from port channel 21 interface, and the other one sent from port channel 22 MAC address. Going back to terminal, after some time, about a minute has elapsed since I was in whiteboard, I'm going to see a whole bunch of errors here telling me that Etherchannel is misconfigured. So I can see here that the port is going into error disabled state, port fastnet 23 and port fastnet 24 and port channel 12 because of something called the channel misconfiguration STP. This is an indicator that the Etherchannel guard actually worked. But Etherchannel guard is very, very flawed. Let me give you an example why. If cat2 is the root of the spanning tree, it will be cat2 that originates the configuration BPDUs. But if cat1 was the root, it would be cat1 that originates the BPDUs. That means that cat2 here will not necessarily detect the problem, and we are going to have a loop in our network. And even if cat2 was the root and sending BPDU frames, this is going to take about 60 to 90 seconds to be detected by cat1. Now, when the ports go into error disable, they need to be removed from the error disabled state. But the good thing is that we can actually see why they were error disabled. So if I go to cat1 and if I do show interface status error disable, I'm going to see that these 3 ports, 2 physical and 1 logical interface, have been error disabled because of the channel misconfiguration. If I see this, I know exactly what the problem is. I have to go back and fix my Etherchannel.